Alright, so in this video, we'll be looking at how to write noble gas electron configurations. This is a more clean and efficient sort of shortcut for writing out longer electron configurations. And so if you've already learned the full electron configuration, which I explained in the last video, so if you missed that, be sure to check it out. This method will just save you time and space, especially for those larger elements. So noble gas configuration is just a shorthand method for writing electron configurations. And so instead of listing the entire configuration from 1s and onwards, we use the nearest noble gas that comes before the element on the periodic table. And we put that noble gas in square brackets and then continue from there. Well, why? You may ask why, and the reason is because, well, the noble gas configuration up to that point is exactly the same, and so we just use it as sort of a base. Explaining this out with, words may seem a bit confusing, but if I promise, when we look at an example, it'll make a lot more sense. So let's just look at an example then. So let us say we want to find the noble gas configuration for sodium. That is over here. So just for demonstration purposes, let's start off by writing the complete electron configuration. So the complete electron configuration for sodium, right? At this point, you should be comfortable writing full electron configurations. So if you are struggling with that, be sure to, click off this video and first be familiar and comfortable with that. But let's assume that you are, and you can write out the electron configuration for sodium. And that is going to be the electron configuration. The complete electron configuration is going to be 1s2, 2s2, 2p6, 3s1. So that's 1s2, 2s2, 2p1, 2, 3, 4, 5, 6, and 3s1. This is going to be our complete electron configuration for sodium. And let's just see that, let's cut off before at this 3s1 here. Let's just put a mark here. And so you'll notice that everything before this 3s1 here, this 1s2, 2s2, 2p6, well, that is actually the electron configuration for neon. That is the electron configuration for neon. You'll see that, again, if we were trying to do that, let's just write it here this way. Well, we would do 1s2, 2s2, 2p1, 2, 3, 4, 5, 6, 2p6. This is the electron configuration for neon. And so you'll notice this is exactly the same as that for sodium, except for this 3s1 that follows the 2p6. And so you can see you can kind of see where I'm going with this, with the noble gas configuration, that especially for writing out the electron configuration for larger elements, suppose we were trying to do bromine here, then we would have to write out all of these, the electrons in all of these different sublevels. That would just take up a lot of time and space. So we can simply use this shorthand noble gas electron configuration in order to alleviate that. And so in this case, you can see that the nearest noble gas to sodium is going to be neon, right? And when I say nearest, it's not going to be the one that comes after. So it's going to have to be the most recent noble gas that has, that comes up in the sequence. So in this case, just looking to our left, we can see that the closest noble gas is going to be neon. And again, noble gases are going to be these guys here, that are helium, neon, argon, krypton, xenon, and so on. And so simply, in order to write our noble gas configuration, in that format, we would just write neon in square brackets, and then 3s1. And this here would be our noble gas electron configuration for sodium. And again, this is showing the fact that this entire portion is exactly the same as the electron configuration for neon, and so we can simply save ourselves a lot of time and space by writing out this square brackets and then continuing the rest that is different. So hopefully that makes sense. It is pretty straightforward. So if you are comfortable with with your regular electron configurations, this shouldn't be something that's too difficult. Let's look at another example. Let's say we want to find the electron configuration for phosphorus, and let's do the noble gas configuration. Noble gas electron configuration for phosphorus. And well, we start by first, if you wanted to kind of look at the steps, first we find the element that we're trying to find the configuration for. Well, that's right here, phosphorus. Now we look to the left of the periodic table to find the previous noble gas. So here we can see that the previous noble gas, well, that's going to be neon. And then we write the noble gas symbol in brackets. So we'll write that noble gas symbol in brackets. That is neon. And then continue the configuration from that point forward. So we write this neon, and then from there, we continue. So that is just going to be 3s2, 3p1, 2, 3. 3p3. And so then our noble gas configuration for phosphorus is going to be just this. So it's a lot easier than if we had to write out 1s2, 2s2, 2p6, 3s2, 3p3. Right? Instead of writing all of this out, we have this nice and neat electron configuration. All right, let's look at another example. Let's say, again, also feel free to pause the video and try to do this on your own. You don't have to follow along at the pace I am. I highly encourage that you pause and try to find it yourself and then check your answer. So let's say we want to find the electron configuration, the noble gas configuration rather, for calcium. Well, again, first let's locate calcium on the periodic table. Calcium is right here. Next, let's find the previous noble gas. The previous noble gas is going to be, well, looking to our left, we see that is going to be argon. So we'll start by writing this in square brackets, argon. And then from there, we will continue on with the electron configuration. So after argon, we move down here and simply get 4s2. And well, this then is going to be the electron, or the noble gas electron configuration for calcium. All right, let's move on to another example. Let's look at the electron configuration for bromine. Bromine. So first, we can start by finding bromine on our periodic table. Bromine can be found right here, number 35. Okay, so we start again. What do? We start by finding the nearest noble gas on the periodic table, which is argon. And then we continue on with the electron configuration from there. And so we would simply start with 4s2. And remember, we're going to have to go to our 3d orbital first before we move on. So that is 3d10 and 4p5. That here is going to be the noble gas electron configuration for bromine. All right. Now let's find the electron configuration for tin, the noble gas one. Tin. Well, first let's find tin on the periodic table. That is right here, number 50. The nearest noble gas, that is krypton. So in square brackets, you have the symbol for krypton, and then continue from there on. That is going to be 5s. 5s2, 4d, 4d10, and 5p2. 5p2. This is going to be our noble gas electron configuration for tin. And so just remember that as we're writing, again, with the schematic that we talked about in the last video, it's just 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, and this kind of cuts off here, sorry. Let me just rewrite that just a second. Here, that is the 5g. And so again, in case you ever get confused as to how this goes, when we're dealing with the larger elements again. Just remember, it discontinue in the similar fashion. So we go 3D, 4P, 5S, then 4D, and then 5P. So as we did here. So again, that schematic can always just be helpful in helping you realize or remember the order in which these different sublevels are filled. Anyway, that just brings us to the end of this video. It's just a quick video to demonstrate a rather simple concept, which is this noble gas electron configuration. Again, we use this just the shorthand method to save time and space. So we always pick the noble gas that comes before the element on the periodic table, and then finish the configuration from that point on forward. It's simple. So if you found this video helpful, please be sure to check out my other videos. Be sure to show your support by liking and subscribing, and leave in the comments what you'd like to see next. And I will see you in the next one.